Dear everyone, I welcome you all for the CHM 132, which is General Organic and Biological Chemistry. In this course, we will learn about the organic chemistry, basically the introduction to most of the functional groups or the different classes of organic compounds. Then we will look at the physical and chemical properties of those organic compounds and some of their reactions. After that, we will learn about the biological compounds and their uses and their importance in the biological systems. So let's start our our lessons with the introduction to organic chemistry. In this chapter, we mainly talk about the hydrocarbons. So, what is organic chemistry? The organic chemistry is the study of carbon compounds. What is carbon? Yes, that is the fourth element. It is an element in the group 4 of the periodic table. So the organic compounds. If I just look at the organic compounds, here you will see in this picture you will see a oil is pouring into a glass of or a jar of water, and we do not really see the mixing of this oil and the water. So we actually have a system here with two different types of chemical properties and physical properties. This oil is an example of an organic compound. So organic compounds may not. Organic compounds are mostly in 99% 9 cases, the organic compounds do not soluble in water. And these organic compounds these organic compounds mainly contain carbon and hydrogens, carbons and hydrogen atoms. But they may also contain other nonmetals as oxygen, sulfur, nitrogen, phosphorus, or any halogen like chlorine, fluorine, bromine, or iodine. So we found these organic compounds mainly in many of our day-to-day life, such as in gasoline, medicine, shampoos, plastics, perfumes. Organic compounds are everywhere. We always use some sort of an organic compounds. So in this course, we learned some of the functional groups of these organic compounds, and the organic compounds are classified according to their functional groups. What is a functional group? Yes, a functional group is the main group that will decide the activity, a chemical reactivity of such a compound. So we call those groups as functional groups. So the compounds which share the same functional groups will have similar physical and chemical properties. This table categorize the properties of organic and inorganic compounds. So organic compounds, what are the elements present in organic compounds? Yes, mainly carbon and hydrogens, and it may contain all other nonmetals. As an example, this is an organic compound. Inorganic compounds are consisted of the metals and nonmetals. like sodium chloride. If we look at the particles of these organic compounds, we call them as molecules. But in inorganic compounds, these particles are consisting of the ions, negative ions and positive ions. The bonding between these carbon and hydrogens or the nonmetals in organic compounds are covalent bonds. In inorganic compounds, the ions are bonded with the ionic bonds. So these ionic bonds are stronger than the covalent bonds. The polarity of ionic bonds are they are polar. They are ionic, so they are polar. But the covalent bonds in the organic compounds, the polarity is zero or negligible. Since the inorganic compounds, they have very strong ionic bonds, their melting points and boiling points are so high. The covalent bonds are weak. Therefore, these molecules are not attached strongly. They can be these molecules in organic compounds can get free easily. So their melting points and the boiling points are very low compared to the inorganic compounds. Since they are not polar, therefore the organic compounds are not soluble in water. But inorganic compounds are soluble in water because they have ionic and polar interactions. The flammability, the organic compounds can easily burn in oxygen, but the flammability is low in inorganic compounds. They do not burn. A learning check. Identify each characteristics as most typical of compounds that are inorganic or inorganic. A. It has a high melting point. Yes, it is a characteristic of an inorganic compound. It is not soluble in water. What is that? Yes, that talks about an organic compound. It contains carbon and hydrogen atoms. Yes, it is an organic compound. It's a property of the organic compound. It has the formula magnesium chloride. Magnesium is a metal and chloride is a non-metal. So this is a inorganic compound. It burns easily in air. The flammability is very high in organic compounds. So this is a property of an organic compound. We talk about the hydrocarbons. The name itself tells you that these compounds contains hydrogens and carbons. Yes, hydrocarbons are organic compounds contain only carbon and hydrogens. In organic molecules, every carbon has four bonds. Every carbon must be connected with four bonds. In methane is CH4. In this methane, this one carbon is attached to four hydrogens. In an organic compound, always a carbon must have four bonds. In so we have different. Okay, so in this, if we look at the Lewis structure of this methane, the carbon atom forms an octet because a hydrogen, if you look at the number of valence electrons on carbon, the carbon has four valence electrons and one hydrogen will bring one electron each. So we have four hydrogens. So altogether the carbon makes an octet around it with the help of the four hydrogens like this. If I draw the Lewis structure, these are the four valence electrons around on the carbon, and these are the electrons brought by the hydrogens. So in a covalent bond, those two electrons are shared among the two atoms. So the central carbon has 8 electrons on it. Next, we can use different types of representations to indicate or to draw the structure of these organic compounds. In methane, look, this the structure was represented by using 5 different types of models. A is a space filling model. B is a ball and stick model. C is a line model. D is an expanded structural formula. E is the condensed structural formula. In every model, the carbon is bonded to carbon has 4 bonds, and those 4 bonds are attached to 4 hydrogens in methane. This is the expanded structural formula. There you will see a bond drawn between these two atoms. This is the representation of a condensed structural formula. We just write there the number of carbons and the hydrogens. The number of each atom will be subscripted like that. So this means this compound has 1 carbon plus 4 hydrogens. The carbon compound that we are going to talk about, the ethane. It has the molecular formula is C2H6. What does that mean? Yes, it has 2 carbons and 6 hydrogens. So again, this is the structure. Every carbon must have the 4 bonds on it. 1, 2, 3, 4. 1, 2, 3, 4. Right. And so those bonds are connected to the hydrogens. So both carbons have a octet around it. So the molecular the structure was represented using these 5 different types of the representations. So here is a learning check. In the butane molecule, predict the shape around each carbon. Okay, so each carbon, these are the carbons. Every carbon has 4 bonds around it. So I know you have taken the general chemistry. Under general chemistry, you have learned the molecular geometries, the shapes. So when you have 4 sigma bonds around a central atom, then that structure will obtain will get the tetrahedral geometry. So the shape would be a tetrahedron. Alkanes. What is an alkane? Alkanes are saturated hydrocarbons. It is a group of hydrocarbons where the carbons, all carbons are bonded with a carbon-carbon single bond. So we call them as saturated hydrocarbons. It's a continuous chain of carbon atoms. So according to the IUPAC system, the International Union of Pure and Applied Chemistry has given set of rules to name these organic compounds. So according to this system, these saturated hydrocarbons, the nomenclature or the names of the saturated hydrocarbons will be ended with ane. Every name will be end with ane. Like this. If it has one carbon, so the name is methane. If it has two carbons, it is ethane, C2H6. If it is propane, it has three carbons and the formula is C3H8. Like that, butane, four carbons, C4H10. Like that, octane has eight carbons. So, the general formula, molecular formula for an alkane can be written as CnH2n plus 2. If the carbons have, if there are three carbons, then how many hydrogens? Yes, 3 by 2 is 6, 6 plus 2 is 8. Okay. So it's an easy way to remember the molecular formulas. So again, if we write the condensed structural formulas, this is the expanded one. Carbon is drawn, bonds are drawn, and the ends connected to hydrogens, and this is that condense the unit. So if it is something drawn like this, we can condense it to a CH2 group like this. You need to draw these two bonds like that. A simplified structure of organic molecules are known as the line angle formula. It is a zigzag line. The the ends of each line, the ends and the corners of this structure have carbons. The ends and the corners, ends and the corners represents the carbons like this. In ends and the corners have carbons. So then how do you get the molecule of the expanded structural formula? Yes, you just add the hydrogens. So let me draw it. So this is the end carbon. It has one bond, so there must be three hydrogens. So this is a corner carbon, so it has a CH2 group. This is a corner, so it has a CH2 group. This is again a corner, has CH2 group, corner CH2 group, and end is a CH3 group. Okay. So ends are connected to three hydrogen atoms. The middle, the corners, or uh, the central, the connecting parts are connected with CH2 groups. Next, you will learn how to draw a formula for an alkane.